Welcome to Ask and Learn.
Our domain here is x cannot be 0 because of the denominator. We have an intercept at negative cube root of 4, 0, but let's just estimate so that we can see our graph. So negative 1.60 is our estimate of the intercept. No symmetry. For asymptotes, we know that x equals 0 is 1. As we previously stated, the denominator of a rational function cannot be 0. So x cannot be 0, therefore x equals 0 is our vertical asymptote. So let's look at slant asymptote now. We can do polynomial division. So this is the numerator, and this is the denominator. Okay, how many times can x squared go into x cubed? We're left with x. X times x squared would normally be x cubed, but we're going to switch the sign so that we can cancel out the first term. Bring down the 4. So we can no longer do polynomial division. Therefore, y equals x, our quotient, is our slant asymptote or oblique asymptote. Okay. And next we can do our first derivative test to find increasing and decreasing intervals, or maxes and mins. So y prime is x cubed minus 8 quotient rule over x cubed. Set that equal to 0, critical point at x equals 2. And by the way, if we substitute f of 2, we will get 3, just so we know the y value. So we're testing 2, and just so we know, f of 2 is 3. It's going to be decreasing in this interval and then increasing here, so that this is a minimum value, local minimum value at 2, 3. Oh, and remember, this was using the first derivative test, so this is f prime. And now we can do second derivative test. So y double prime is 24 over x to the 4th, but that's inconclusive. We cannot use it. So we can't look at concavity, but we can use the first derivative test. Okay, so now we can make our graph. So let's say this is 1, this is 2, this is negative 1, negative 2, this is 1, this is 2, 1, 2, 3. Okay, and asymptotes at x equals 0, which is, we have x equals 0, and y equals x. It's this diagonal line. Okay, we have an intercept at negative 1.60, which is approximately here. This is a rough sketch. And we have a local minimum value at 2, 3. So 2, 3. It'd be about here. This is just a rough sketch. So our graph approaches but never touches our asymptotes. So at 2, 3, it's going to go like this. And like that. And why is that? Because it's going to be decreasing and then increasing. Decreasing and then increasing. And then over here, we know that it's going to go up from the axis and approach but never touch our asymptote. And then same here, it's going to approach but never touch until it hits the axis. And this is a rough sketch of the graph.